Welcome. We will begin our discussion of statistics with some basic concepts and definitions. The first thing we want to focus on is the definition population. The population refers to all the items of interest. And if we want to ask a certain question, instead of posing it to all the members of the population, we can instead find a sample. A sample will include some, but usually not all, of the target population. Let's apply these definitions to our next example. We read that a group of librarians is interested in the number of books that library patrons check out from the library. The librarians examine the checkout records of 70 randomly selected adult patrons. From this example, identify the population and the sample. What do you think the population and the sample are in this example? The population is the adult library patrons, and in order to investigate the habits of those adult library patrons, they select a sample of the 70 adult patrons. Now, statistics is divided into two main areas of study. The first is descriptive statistics. Descriptive statistics will collect, organize, summarize, and present data. The next category is inferential statistics. Inferential statistics will draw inferences or conclusions about entire populations based on information gathered from the samples. Our next definition are the different types of data. We have two types, quantitative data and qualitative data. In quantitative data, think quantity. It focuses on qualities that can be assigned a numerical value or measure. So some examples of this are age, weight, cost, temperature, quantity, time, and speed. Qualitative data sounds like quality is often non-numerical, and it will focus on information that's more descriptive, things that could be observed by our five senses. Some examples of this are an item's color, its texture, or smells. Let's see these types of data, qualitative and quantitative, in our next example. Suppose a researcher is observing a cat. What are some examples of quantitative and qualitative observations they could make? So remember, quantitative observations describe things that can be measured, and qualitative data are things that are more descriptive in nature. I would encourage you to pause the video and think of a few examples of quantitative and qualitative information. Some examples of quantitative data about this cat could be its age. We could measure that as a number. Its weight, the number of whiskers on its face, how much it eats. Some examples of qualitative data could be the color of the cat, whether the cat has a tail or is naturally tailless, the cat's temperament, whether it's friendly or shy. Things like that are examples of qualitative data. Now let's imagine that we gave a survey out to our sample population and we collected their results. In the results, if it was a quantitative question asked, we got a lot of numerical answers back as a result. But looking at the collection of responses, we might not be able to draw inferences so well if we're not able to organize the responses. We need to organize the data in such a way that we can start to see the patterns. One way we can organize data is through frequency distributions. The goal of a frequency distribution is to tell us how often a particular data item repeats in the data set. So we will list the data values, X, and then next to it in a T-chart we'll list how many times they occur, which is their frequency, F. So for the data set I've drawn at the top of the screen, we have the values 1, 1, 2, 2, 2, 3, 4, and 4. And if we were to draw a frequency distribution of this data set, we would do so by making a T-chart. On the left side, you list the data items that occur. So the data items are 1, 2, 3, and 4. And then on the right side, you write their corresponding frequency. So we count how many times does 1 occur in our data set. 1 occurs 1, 2 times. so its corresponding frequency is 2. If we count, 2 occurs 1, 2, 3 times, so its corresponding frequency is 3 times. Continuing this, we see 3 occurs once, and 4 occurs twice. So this is our example of a frequency distribution. Next, we'll discuss the idea of relative frequency. So a relative frequency will describe the amount of times an item appears relative to the total number of items sampled. So we're going to take the frequency and then divide it by the total number of observations, and that's what takes our value n. So for our same example of the data set above, let's calculate its relative frequency distribution. So for the same data set, it will begin, always the relative frequency begins with just the plain frequency distribution, so we found that above. So I'm just going to recopy it here. 1 occurred 2 times in this data set, 2 occurred 1, 2, 3 times in the data set, 3 occurred once, and 4 occurred twice. Now what makes it the relative frequency is adding this third column where we have the frequency divided by the number of items surveyed. So let's see how many items were originally surveyed. We have 1, 2, 3, 4, 5, 6, 7, 8. So the original number of surveyed items was 8. So for each of these frequencies, I'm now going to take the fact that 1 occurred twice and say the relative frequency was 2/8. 2 occurred 3 times, the relative frequency of that was 3/8. The number of times 3 occurs is once out of the 8 options, and then the number of times 4 occurs is twice out of the 8 options. So this portion of the table that I've highlighted in pink is what makes this now a relative frequency distribution. Now in our next example, we are told that 15 members of a class were polled about the number of siblings in their individual families. We're then asked to construct a frequency distribution, so we'll do that first, and then a relative frequency distribution based on their responses. And we see the responses given here. So always when we're asked to construct a relative and a frequency distribution, we always go with the frequency distribution first, and we'll make our table. We always begin with x on the left, and those are our data set values. And let's look through the list. We see that we have a 1, 2, 3, 5, 4, and 6. So it looks like we have data values 1 through 6. So we'll make a table for each of those. And then to complete the frequency distribution, we then on the right side of the column have the F for the frequency, and let's count how many times each of these items occurred in the data set. The item 1 occurred 1, 2, 3, 4 times, so its frequency is 4. The item 2 occurred 1, 2, 3 times, so its frequency is 3. The item 3 occurred 1, 2, 3, 4, 5 times, so its frequency is 5. The item 4 occurred once, so its frequency is 1. The item 5 occurred once, so its frequency was 1 time. And finally, the item 6 also occurred 1 time, so its frequency is also 1. Now this so far completes our frequency distribution. In order to add to the relative frequency distribution, we can add one more column to this table. And in this column, we will head it with the title F divided by N. So that's the frequency for each data item divided by the total number. If we look back in the original phrase, we see the total number is 15 members. And we can find that as well if we count up each of the individual data items. So the relative frequency is that for the item 1, it occurs 4 out of 15 options. See that we're getting the 4, it's the frequency that the item 1 occurs. The 15 is coming from the idea that there are 15 data entries. So the relative frequency that item 2 occurs is it occurs 3 of the 15 times. The relative frequency of data set 3 is that it occurs 5 of the 15 times. And if you would, think about how you would answer for the relative frequency of data item 4, 5, and 6. The item 4 occurs 1 out of 15 times, as do 5 and 16. So with that, we have made our frequency distribution here, and then paired next to it, we have our relative frequency distribution. Now if we're given a data set and we'd like to organize the information that we just found in our frequency distribution, we could do so in a very nice way. And we might have seen this idea before as a bar chart. That's the idea of a histogram. So bar chart, histogram, same idea. And using the data from the previous example, our question to the 15 students about the number of siblings they had, we see it organized here. Let's create a histogram for this data. To begin, we create a horizontal and a vertical axis. And for the histogram, the vertical axis will always be the frequency that something occurs, and then the horizontal axis will always be whatever we're measuring. So in our last example, it was the number of siblings, so we'll label this number of siblings. And before we start creating our histogram, we need a frequency distribution. Now this is the exact same example as we just did, so let's copy down the frequency distribution that we found from our previous example. So from the data set, we would create our frequency distribution, which we can see on the left side of the screen, and then from that we make our histogram. So the way the histogram works is we glance through all the possible frequencies, and we see they can vary between numbers of the smallest 1 up to the highest of 5. So as we label on our vertical axes, we will choose values from 1 to 5. And then for the horizontal axes, we will look at our data set and see what are the different values that responded. And we see that students responded with digits 1 through 6, so that will be our horizontal axis. And then to complete the histogram, we give the bar chart aspect of it. So we see if we had one data item, the frequency was that it occurred 4 times. So we can show that with the bar chart where we go from 1 to about halfway between 1 and 2, and then our bar chart should rise to height 4. Next up is data item 2, and we see it occurred 3 times. So that would give us this portion of the bar chart. And we continue in this way throughout our entire frequency distribution. So for data item 3, it occurred 5 times. And then we see that data items 4, 5, and 6 all were of frequency 1. And that is how we can make our histogram based on our frequency distribution. So from this, we can quickly visualize and see that the data item 3 was the most frequently occurring data item. Specifically, it occurred 5 times. Data items 4, 5, and 6 were the least occurring responses, and they all occurred 1 time. Another way that we could describe the information given in a frequency distribution is by a frequency polygon, otherwise known as a line graph. To draw a line graph, we would start in the same way as the histogram, draw a horizontal and vertical axes. And as before, we would label the vertical axes as the frequency that the item occurs. And the horizontal axis is always what we're measuring. So in this last example that we were working with, it was number of siblings. We look through the frequency and we see the occurrences vary between 1 and 5. So on my vertical axes, I'm going to label 1 through 5. And then we see the data items vary between 1 and 6, so we'll label that on our horizontal axes. Then to create the frequency polygon or line graph, we look at each data item and we see its frequency, so 1 occurred 4 times. So I'll go to the item 1 and I'll plot the point at 1, 4. Next, we look, the data item 2 occurs 3 times, so I go to the data item 2 and I plot that it occurred 3 times. And we continue this throughout the entire frequency distribution. And then finally we see at the end, items 4, 5, and 6 all occurred 1 time, so we can plot those. And then to finish this up, we need to draw a line connecting these dots in this way. We always start at the cross section where the horizontal and vertical axes meet, and then we go up to the first point. From the first point, we go to the second point. From the second point, we go to the third point, and we continue in this way until we've connected all the points from one to the other. And that would be our frequency polygon or line graph. Now imagine we gave a survey about, for instance, the number of siblings to 100 people, and we got 100 different responses. With data sets that large, drawing a frequency distribution or a relative frequency distribution might be rather complicated just because there's so many possible responses we could get, so many different rows of information. So for very large data sets, we'll often find it useful to create what's called a grouped frequency distribution. And there, instead of being interested how many times a particular data point occurs, we might instead be interested in how many occurrences of the data fit in these ranges. How many of the data values will fit in the range 0 to 10? We would count and put their frequency next to it. How many of the data values fit in the range 11 to 21? We would count and put that next to it. And we would continue this until we've gone through all the different ranges that could comprise our data. Now, when making a group frequency distribution, in general, there are certain guidelines that we would use to create these data classes. Let's go over these guidelines. The first guideline is that we should make sure each data item would fit into one and only one class. Next, we should make sure all the classes are of the same width. So for example, we would not want to create a frequency distribution like this where one of the groupings was 0 to 10, but the next grouping went from 11 to 100. This example violates the guidelines because the first group has distance 10 and the next group has distance 89, so they're not the same width. So this is what we want to avoid. Next, we want to make sure the classes do not overlap. So for example, in this problem, this would fail guideline 3 because we notice the first grouping goes from 0 to 10 and the second grouping goes from 10 to 20. Because of this overlap, this is an example of something that would fail guideline 3. We want to make sure they do not overlap, so to correct it, we could restart the second grouping at 11, and if we wanted it to be distance 10, as the first one would, we would go up to 21 instead. So that corrects the idea that the classes do not overlap. And then as the goal of this is to create a smaller diagram that we can look at and extract patterns, we would not want to use many more classes than 12. Too many classes and we lose the ability to really understand the data at a glance. And then too few classes can obscure the data as well. We don't want too large of a groups. So in general, we recommend between 5 and 12 classes. And at least for our class, in our quizzes and exams, you'll always be told in the problem how many classes to use. Let's go through our example of a grouped frequency distribution. So in this example, we are told that 30 students have been selected randomly from school, and we're asked to estimate the number of hours they spent on schoolwork in the past week, both inside and outside of class. Their responses are shown here. From this data, we're asked to first create a group frequency distribution, then a grouped relative frequency distribution, and finally, a histogram for the data. Let's begin with our group frequency distribution. Here we see that we are asked to use 7 classes. So how do we work with this and figure out the width of the grouping? So we want to say how many data items occur between this and this group. The way you would do that is to always follow these steps. Step 1. Find the largest data item. Look through our 30 responses and spot the largest data item that you can find. If we look through all 30 responses, 42 is the largest response we see. Then we'll divide that largest data item that we just found and divide that by the number of classes. In our case, we were asked to use 7 classes. And we would get 6. Now this 6 is the width of each class. So that's the process you can use to find the width of each class. And now we need to know, where do we start? Because we know each class should be distance 6, but it's distance 6 from what? To know that, you glance and you try to see where about are the smallest or starting data values. So I'm going to highlight a few of the smallest data values from our 30 responses. So just glancing through the data values, I see items like 3, 4, 5. Those are the slowest data responses. So since those are very close to 0, often a nice starting point if you have data values occurring at the low end of the integers, positive integers, is 0. So let's start there. For our group frequency distribution, we start with a t-chart. On the left are our data items, on the right are their frequency. Now we just said we're going to start at 0. And if we go to 0, we need to add 6. And we see if we add 6 to 0, we get to the data point 6. So our first data class are items 0 through 6. Let's continue creating the rest of the classes, because we know we have to go until we include the highest value of 42, and there will be 7 of them. So we know we don't want our classes to overlap, so instead of starting at 6, which we just ended on, I need to start the next integer over, so we start next at 7. We know each class has width 6, so we add 6 to 7. And we get the value 13, so our next class goes from 7 to 13. And we continue this until we cover all possible classes. We ended the last at 13, so the next class picks up at 14. Add 6 to 14, and we see the next class should end at 20, and we continue. We start at 21, add 6 to that will take us to 27. Next, we start at 28, add 6 to that, and that will take us to 35, add 6, and we get to 41. And then finally, our final class will go between 42 and 48. And the reason we stop here is that now we've been able to include up to our highest value. And if we count, we have used 7 different classes. So the setup part is done. Now we just have to carefully read through the data and make sure we do not miss anything. So for our first group, we want to count how many objects occur between 0 and 6. Now I've marked some of them already, 5, 4. So we read through the first row. No other object in the first row is between 0 and 6. Go through the second row. Nothing here between 0 and 6. Our final item on the third row is the 3. So we would record that there are 3 items that occur in the 0 to 6 class. Next, let's find the items that occur in 7 through 13. Always go through the list in an orderly fashion. Try not to miss anything. So anything that's between 7 and 13 I'll mark. So 10 gets marked. 7 gets marked. 12 is marked. 8 is. 14's a little past. We don't include it. 11. 9. We include 13. We include 8. Next row. 12 is included. And I believe that's it for this. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 items in the grouping between 7 and 13. Let's continue with the groups between 14 and 20. We mark anything that lives in the range 14 to 20. 18 is there, 20 is there. Nothing else in the first row is. 14 belongs there, as does 16. Nothing else on the second row. 14 on the third row, and 16 on the third row. Let's count. That's 1, 2, 3, 4, 5, 6. 6 items occur in the range of 14 and 20, so we record that as that group's frequency. From the range of 21 to 27, we see 22 belongs there, as does 24, 27, 26, 25, and 24. So if we count, that's 1, 2, 3, 4, 5, 6 occurrences in this group. The next group, 28 to 34, we have 33, 31, and 31 again. There are 3 occurrences in this group. Our next group is 35 to 41. Looking through the data items, only 35 and 40 belong to this group, so there's 2 in that. And then our final group is 42 to 48, and only 1 item is in that group, our largest item of 42. So in this way, we've gone through all of the data items and categorized how often data items occur in our 7 different classes. So where are most of the data items, which class do most of the data items lie in? We can look at our frequency distribution. And we see that from 7 to 13 is the range that has the largest data values of our 7 different options. So we've completed the first question. Now let's continue to get our group frequency distribution. And we know for grouped frequency distributions, all we have to do is add an extra column where we relate the frequencies that we just found to the overall number of items in the survey. So earlier, we read in this example that we surveyed 30 students, so our N is 30. So for the relative frequency distribution, we take the frequency and we divide it by the total number of responses. So for the range 0 to 6, there were 3 frequent occurrences, so we say 3 divided by 30. For our next grouping, 7 to 13, we see that there are 9 occurrences, so the relative frequency is 9 over 30. Continuing in this, we see that for 14 to 20, since there's 6 occurrences out of 30, its relative frequency is 6 out of 30, as is the next group's. 28 to 34 had 3 occurrences out of 30. 35 to 41 had 2 occurrences out of 30, and our final class, 42 to 48, had 1 occurrence out of 30. So with that, we've completed our group relative frequency distribution. So finally, from this frequency distribution, we can create our histogram. And we know when it comes to a histogram, we begin by a horizontal and vertical axes, where the vertical axis is always the frequency. The horizontal axis is what we're measuring. In this problem, it was hours spent on schoolwork. And then to label our vertical axes, we look at the frequencies that we recorded to see what range of values we should include. Looking at the frequency, we see they take on values at the lowest 1 to the highest 9, so let's mark that on our axes. And then our data entries, our number of hours spent on schoolwork, well, we'll take the classes that we found here and list these on the horizontal axes. Finally, we'll look at each of the classes and record their frequency. So we see for the class 0 to 6, it had a frequency of 3. Next, for the range 7 to 13, it had a frequency of 9. And then we can continue to draw the rest of the histogram from our frequency distribution. So we see that the ideas of frequency distribution and grouped relative and relative frequency distribution in histograms all carry over to our idea of the grouped frequency, relative frequency distributions.